Here we go. Again, so we'll go back. Am I sharing this screen here? No, I want to share this screen here. Can everyone see that screen there?
Yeah.
Okay, cool. So an IP address operates at layer 3 of the OSI model. So we talked about the 7 different layers that you have: application, presentation, session, transport, network, data link, and physical. It provides a logical IP address for devices to communicate with each other. We won't be like networking is all about communication. If you want to communicate with your friend via letter, you know, via a postal system, you write your letter, you put it in an envelope, and you put an address onto it, because the address uniquely identifies that person where they live via postcode or whatever. But IP address uniquely identifies a device out on the internet where that device lives. If we didn't have an IP address, then communication would fail. Okay, so it's 4 octets, or 4 bytes. Now, another caveat I'm going to put out here right away is that anyone that's never subnetted before, it takes a while to get used to this. Okay, you know, if you have no idea of what an IP address is, if you've never looked at this before, you know, you are going to be confused for a couple of hours. You know, it's my job, hopefully by 10 o'clock, you know, to be a light switch coming on, or even tomorrow, because we're going to go back over tomorrow again. And then again, it's up to you during the week to go over and over it again as well. Like, it does take a while. It's not an easy topic. Another thing, there are lots of different ways of teaching subnetting. I go by actually CISCO's preferred method, which is the way I learned it, and it's probably the most logical way of teaching it as well. Some teachers use what's known as magic numbers and stuff like that. I don't like using magic because it's just math. There's nothing magic about maths. It's just logic. Yeah. Okay. So we got an IP address. IP address is 10.10.10.10, or that's an example of an IP address. I don't like using that example, so I'll use a different one here. You could use 192.168.10.1. Yeah, split into 4 octets or 4 bytes. I'm going to come back to that later. Okay, each octet is separated by a dot. So you say 192.168.10.1. Okay, so you got your first octet there, you got your second octet there, you got your third octet there, and you got your fourth octet. Okay, an IP address can be put down in one of 3 different classes. So you got 3 different classes: class A, class B, or class C. And I'll talk about that in a minute, the 3 different classes. When you have an IP address, you will have a number that will accompany the IP address, and that number is called a subnet mask. Okay, and the subnet mask's job is to separate the network part of the IP address from the host. The network part from the host. Okay, so every IP address, they'll be broken into 2 different areas. You got the network part and you got the host. So the rule is, for now, this will change as we start getting more into subnetting. The rule is, when you look at a subnet, when you have 255, that represents the network, and 0 represents the host. So 255.255.255.0. And you can actually just get, it's like in a red line here, and dividing the network part of the address from the host. Okay, I might get a little bit confusing there. Okay, so you could say that this is a PC, and this PC lives in the 192.168.10 network. Okay, so when you have an IP address, the 255 is the network part, the 0 is the host. You can say this is host number 1 in the 192.168.10 network. Does that make sense?
Yeah.
Okay, cool. This is very important, because when you come to communication, if devices in the same if you have two devices connected into a switch and they're on different networks, they won't be able to talk to each other. They won't be able to talk to each other because they're on different networks, and switches, we talked about this already, switches provide communication between devices within the same network. Okay. Right, we'll move on that slide there. But very important, 255 of the subnet represents the network part of the address. 0 of the subnet represents the host part of the address. Okay. So we said there's 3 different classes. Class A, Class B, and Class C. Okay, so you have 3 different classes of addresses. You know a Class A because the IP address, the first octet or the first part, so octet is just a fancy word for a part. Okay, the first part of the IP address is between 1 and 126. Okay, so you have 10.5.1.1, that's a Class A. Why? Because the 10 here, this octet lies between 1 and 126. Class A addresses have a default subnet mask of 255.0.0.0. So remember, I'm going to keep this up here. When it comes to your subnetting, 255 is equal to the network part, and then 0 is equal to the host. Two 255 represents the network part, 0 represents the host. Okay, so what network does this PC live in? So this is a PC, 10.5.1.1 is a PC. Well, it lives in the 10 network.
10.
Just a 10.
Yeah.
Yeah, because the other 3 parts are zeros. So you could get the red line here and just mark it across. So this PC lives in the 10 network. So it's in 10.0. I'm going to try and keep the blue part of the address as in the network part, the red part as the host. So this PC 10.5.1.1 lives in the 10.0.0.0 network. Yeah. If we look at that network, so that's the very first IP address in the 10 network, 10.0.0.0, because counting begins at 0. Now, what's the very last IP address there? So the first address is 10.0.0.0. The very last address in that network, in the 10 network, well, they're all, what do they have in common? All PCs in the 10 network have what in common? They're all in the 10 network. They're all live in the same network. Like if I have a street, Willow Green, and there's 15 houses on Willow Green, what do all those houses have in common? They all live on the street Willow Green. So all these PCs, all these hosts, because a host is just a PC. A host is a PC or a server. It's just one device. Just think of it that way, okay? So the very first network is 10.0.0.0. The very last address is 10.255.255.255 because in IP, it always goes from 0 to 255. 255 is the very last possible address. You'll never see an IP address. You never see an IPv4 address, which is what we're covering now, with a 256. You never see it. You may see with IPv6, but not with IPv4. We will be looking at IPv6 sometime. Okay, does that make sense?
Sorry, can I just ask there,
Sure.
is the only way to identify it as a Class A IP by the subnet mask?
not by the subnet mask.
So can you identify?
The only
Just
way
by
to identify it is by where the first octet is, not by the subnet mask. The subnet mask is flexible. The subnet mask can be changed. I could have a class A with 255.255.255.0. If
Okay.
you have a look, the only way to identify what makes a class A address is where the first octet is. So this is a class A address because the 10 here is in between the 1 to 126. It's a great question. I'm going to come back to that as well. Okay.
Cool. Thanks.
Okay, if you look at the class B here, right? Let me just try and give it a bit more space here on this. I hope people can see this. If you look at the class B, so the class B, the first octet is always between 128 to 191. Okay, so here, this is a class B address because the first octet is 150, and 150 lies between 128 and 191. It has a default, class Bs have a default subnet mask of 255.255.0.0. Like I said, default just means starting out. That's all. It can be changed. Subnet mask of 255.255.0.0. So this PC here, right? This PC or this host 150.51.233.1. Where's our red line there? It's in there. Where's our divider between the network part and the host part? Here, isn't it? Because the first two octets of the subnet mask represents the network. 255.255.0.0. Remember, 255 is the network, 0 is the host. So what network does this PC live in?
151.
150.51.0.0. Yeah. Because the first two parts of the IP address are blue because they represent the network. I'm going to try and consistently do the blue part of the IP address is the network part, the red part is the host. There's no rule to say that. I think just some people find it easier when they see colors to learn. So the last address will be what?
150.51.255.255.
Yeah, that's it. Because what do they have in common? All these devices in the 150.51 network, what do they have in common? They all live in the 150.51 network. Okay, all right.
Yeah.
Yeah.
Okay, class C. You know a class C because the first octet of the IP address is between 192 and 223. So here, this guy here, 220, lives between 192 and 223, 220.1.50.63. And the default subnet mask or starting out subnet mask of 255.255.255.0. So it's like we're moving our red divider another part across, aren't we?
Yeah.
So it's in the third octet here. So where does this PC live in? What network is this PC in?
220.1.50.
Yes, exactly. So this PC lives in the 220.1.50.0 network. First address.
Is there any reason the class C octet doesn't go to 255 and stops at 223?
Yes, because 224 is reserved for multicast, and then after that you've got experimentation addresses. So they're just reserved. So the very last possible address is 223. Yeah.
Is it the same then as well for 127 as well between A and B?
127 is reserved as but it's your loopback, it's your TCP/IP stack. it's like your home address. So if your PC, if there's a problem with your NIC card or your network card, what you can do to check if the hardware is okay, you can do a ping to 127.0.0.1. It's considered your home address. You can get these geeky t-shirts that says there is no place like 127.0.0.1. There's no place like home. Okay, does that make sense? So you have, so which if looking at here now, which network is the biggest? Which, when I say the biggest, which network can contain the largest amount of addresses?
Class A.
Class A, yeah. Class A. This Class A network here, this 10 network on its own could have over 16 million addresses, or 16 million addresses here. In the same network, just within the 10 network. All those 16 million addresses will range from 10.0.0.0 to 10.255.255.255. Class B is a little bit smaller, but still big. Class B will have 65,536 addresses. 65,536 addresses. So to put that into scale, all of this one network, the 150.51 network, 65,536 addresses. So to kind of give you an example of that, let's say you had a very, very large switch, and this very, very large switch had 65,000 ports. You could connect 65,000 laptops into this large switch, and all of those laptops would be in, they would all be within the 150.51 network, somewhere in here. All right. Class C, now it's hard for you to kind of imagine 16 million addresses in the 10 network. And it's even hard for you to imagine 65,000, like it's like Crow Park, well, a little bit less than Crow Park, but 65,000 within a Class B. But it's pretty easy to see, if you look, how many addresses in a Class C network, isn't it? How many addresses here in this network, the 220.150 network? The first one is 0 and the last was 255.
256.
You've got 256 addresses. Okay. Now, I want to make a very clear distinction between two different things. I want to make a clear distinction between the number of addresses in the network and the number of usable hosts. Because there is a rule when it comes to subnetting that every single network, you cannot use the very first IP address and you cannot use the very last IP address. The very first IP address is considered the network ID. You can't use it. Unusable. When I say you can't use it, you cannot assign it to a device. So here, the very first address is called the network ID, and the very last address is reserved as the broadcast. So when you have and this is the same even with Class A or B or C. So this Class C network here has 256 addresses. How many devices could you possibly get on this network here? 254 hosts. Excuse me. Yeah. Class B, 65,536 addresses. 65,534 hosts. Because you can't use the very first address and you can't use the very last address. 16 million addresses, 16 million minus 2 for your hosts. Let me show you. Let me go on to view network connections. Excuse me. Where is this one node? I go in here, I better not go in here, but I better not try and change this because it'll actually, yeah. But if I wanted to, so if I want to change it in here, I better not because I don't even have wireless. I won't do it on the PC here because my Zoom call will go and I kick everyone off. Let me just do it on packet tracer. Okay, so we've got PC here, right? If I go into this PC and I assign this PC up on packet tracer, where is it? The very first address here, 221.50.0. Yeah. So I went here, 220.1.50.0, and I use look, invalid IP address for the subnet mask. 220.1.50.0. They won't let me do it because packet tracer saying you can't do that. That's a network ID. I could use 220.1.50.1. No problem. I change it to 0. See that? So my operating system won't do that, or packet tracer software won't let me do it. And I can't do the very last one either. I can't do 220.1.50.255. Getting a message. So any questions on that? So you need to understand the difference between an address and a usable host. 256 IP addresses, 254 usable hosts. Okay, close up there. So in order to actually understand how to subnet, we need to first look at binary, okay? Because we talked about this before. Everything that was converted, everything that is sent across a line or a computing device, even a system bus, even the hardware, a motherboard, even the data that is read onto a drive, it's all just ones and zeros. It's just electrical signals. And it's the same with subnetting. So those ones and zeros, you need to, in order to know how to subnet, you need to bring it back to ones and zeros, okay? And binary is the counting system for those ones and zeros. So binary is a counting system where we got two values. Binary, we got two values, either 1 or 0. That's it. If we look at decimal, which is the human counting system, we have 10 values. Decimal figure can be anything from 0 to 9. A binary character can only either be a 1 or a 0. Okay. The reason why we use decimal is because we got 10 fingers. Well, we can take, let's take a decimal figure here, or decimal number. Let's say 59. And let's just break that down a second. What does this 59 represent? 59 here represents 9 units of ones, 5 units of tens. If I add another character, if I said 759, then it would be 7 units of 100. I could keep going and, you know, to infinity and beyond, 8,000, and you'd have 8 units of thousands. This is a decimal figure. Why is it going 1, 10, 100, 1000? because it got values of 10. So each time you move across, you're multiplying by 10, and you can keep going, but you have to multiply by 10. Binary, we've only got 2 values. So in binary, you start on the right and you multiply by 2. You got 1, you got 2, you got 4, you got 8, 16, 32, 64, and 128. Now, why am I not going no further on? Because if we looked at the start, an IP address is 4 octets or 1 byte. 1 byte. How many bits does it take to make a byte? There is 8 bits in a byte. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits in a byte. But the thing is, right, we can take this decimal figure of 59, and we can use it to find the binary equivalent. Okay, you're going to need, in order to know how to subnet properly, you're going to need to know how to convert from binary or from decimal into binary and from binary into decimal. It's easier to go from binary into decimal than it is from decimal into binary. Right, so this is 59, this is our decimal figure. Yeah. How do we get the binary equivalent of that? Well, you ask yourself one question. Does, in this case, 59 fit into 128? That's the question you ask. So you start here, you start at 128, and you say, does 59, can you physically fit 59 into 128? No. So what you do, you put down a 0. Because 0 means there is no value of 59 here. And you move across. Then you say, does 59 fit into 64? Does it? No. Sorry, I'm getting mixed up here. Going backwards. It's been a while. Does 128? I was thinking that looks weird. Does 128 fit into 59? I was looking up. 59 does fit in to 59. Yeah. So you're saying, does 128 physically fit into 59? No, because it's too big. 128 does not fit into 59. Does that make sense?
Yep.
Then you move across. Does 64 fit into 59?
No.
No. Then you move across. Yeah, so you put down a 0 and you move across. Now, does 32 fit into 59?
Yeah.
Yes. So what do? You fit it into 59. You put it in. How do you put in? You put a 1 value to indicate there is a 32 numerical value in here. And you put it in and you subtract. Because what you're doing is you're fitting 32 into 59. You subtract and you're left with 27. So what you do, you move across and you ask yourself, does 16 fit in to 27?
No.
It does, doesn't it? Does 16 fit into 27? Can you physically fit this character here, 16 and 27? Yes, you can. So you put down a 1 and you subtract and you're left with 11. Does 8 fit in to 11? Yes?
Yeah.
Put down a 1 and subtract and you're left with a 3. Does 4 fit into 3? No, it's too
No.
big. So you put down a 0. Does 2 fit into 3?
Yes.
Yes. Well, if you think there's 2 and 1 make 3, so you can put down a 1 here and a 1 here. So the binary equivalent of 59 is equal to 00111 Now, how would you check that out? If you wanted to make sure that it's exactly correct.
Add them all up together again.
Add the values that have the 1s. because that's all we did. We're just making the values. So if you start 32 and 16 is 48, and 8 is 56, and 2 is 58, and 1 is 59. I didn't add the 0. I didn't add the 4 value here because, and I didn't add the 128, I didn't add 64. You're not going to add a 128 because straight away you're going past the 59 value. Does that make sense, guys?
Yep.
There's a calculator you can have
Yep.
as well. Programmer. And you can say 59, and you can say binary equivalent to 0011 1011. 0011 0011 1011. Okay. Okay, so always have that table, especially if you're new to this. Always use that table. And if you have a spare pen and paper, maybe we'll get you to do a few of them now yourselves. Okay.
Right.
All right. So I'm going to get you to do, let's say, and I want, yeah. So actually, I'm going to do another one. Let me do one more one, right? So actually, well, to do this one here was 59. So 59 again. Let me just go back to 59 for a second, right? 59 was 00111011. 32 and 60 is 48, 56, 58, 59. Yeah. Now I want to say, how many bits did it take us to make the value of 59? How many bits?
Well, would we say we had to use all 8 bits?
4 bits.
4 bits. Anyone else?
6.
6. Yes. 5. Okay. Have a look. When you say 59, right? Do you say? Do we say 0059? As
No.
no, why not? Because we don't have any thousands and we don't have any hundreds. So we just don't put them in. It's the same here. So you could say 00111 011. What you do, you can eliminate your leading zeros because we don't have a 128 in the number 59. We don't have a 64 in the 59. We have now you can't leave, you have to leave this 0 here. Like there's a big difference between 59 and there's a big difference between eliminating those zeros there. 0059 is still the same as 59, but if I went 509, I can't get rid of that 0 there because that 0 is needed, isn't it, to make 509. So I can't get rid of this 0 here because it gives the IP address, it gives it its structure. Does that make sense? So 6 bits. If you think about it, how many decimal characters does it take to make 59? 2, 5, 9. How many decimal characters does it take to make 509? 3. If I had, how many decimal characters does it take to make 509 there? 3, because you can drop your leading zeros. 1, 2, 3. How many decimal? How many bits does it take to make 59? 1, 2, 3, 4, 5, 6. 6 bits. Is that okay? Does that make sense?
Yep.
Okay.
Yeah, makes sense.
Good. Cool. All right. So we'll give you. Do you want me to do another one, or do you want to do some yourselves? I'll go back over it. You learn more by doing it yourself.
Give it a go.
Yeah.
You know
give it a shot.
the last one was at 32. Isn't like 2 in the power of 5 is equal to 32. So would that not be 5 bits?
So yeah, I'm gonna let me come back to that, Egbert, because there is a rule that it can that we can do that because counting begins at zeros, it gives you a skewed result.
Okay.
Okay, I'm gonna come back to that later on, because I don't want to. That is going to confuse some people. Okay, and that's a sort of it's one of these. It's only these exceptions, but yeah, it's a good spot. But I don't want to kind of confuse everyone in it. You know, there's only certain amount of times that exception will come into play, and the reason why that comes into play is because counting begins at zeros. So
Okay, thank you.
okay, so let's say we have 80 here, right? So it gets us to do some here, right? 80. So I want to find the binary equivalent of 80. I want to find how many bits does it take to make 80. 80, 100, and 255. Okay, so I want you to convert those three values and get the binary equivalent of 80, 100, and 125. Use those tables: 128, 64, 32, 16, 84, 21. And again, ask yourself, does 128 fit into? That's the question. Does 128 fit into 80? Does 128 fit into 100? If it does, add in a 0, or sorry, if it does, put in a 1 and subtract. If it doesn't, put in a 0 and move across. Okay, now I'm going to pause the video while you're doing that, just so it makes the video, you know, more concise. Okay, so you ask yourself, does 128 fit into 80? No, it doesn't. Let's just put down blue. So you put down a 0. Does and then you move across. Does 64 fit into 80?
Yes.
If it does, you put down a 1 and you subtract on your left with 16. Is that correct?
16, yeah.
So you say, does 32 fit into 16? No, it doesn't. Put down a 0 and move across. Does 16 fit into 16?
Yeah.
Yes, it does. Put down a 1 and you subtract. Well, 16 from 16 is 0. But your 8, 4, 2, and 1 don't fit into 0. So you're going to have 0, 0, 0, 0. Yeah. How many bits did it take to make 80?
7 bits.
7
bits.
bits.
Yeah, 7 bits. Yeah. And again, to add up to find that out, you just simply add the values that have 1s and ignore the values that have 0s. 64 plus 16 is 80. Yeah. Okay. First and done. Okay, next one, 100. So does 128 fit into 100? No, it doesn't. Put down a 1. Sorry, excuse me. No, it doesn't. Put down a 0 and move across. Does 64 fit into 100? Yes, it does. Put down a 1 and subtract your left with 36. Yeah. Does 32 fit into 36? Yes, it does. Subtract your left with 4. 0, 0, 1, 0, 0. So 100 in binary is equal to 0, 1, 1, 0, 0, 1, 0, 0. It even looks like 100. Yeah. And to check that out, 64 plus 32 is 96 plus 4 is 100. How many bits? 7 again.
Bits.
Yeah. Okay. Is that okay? Any questions with that?
No.
Okay, cool. The next one. 255 is an interesting one, isn't it? Let's get this here. 255. So basically 255. So you start off with, does 128 fit into 255? Yes, it does. You subtract and you're left with
127.
127. Does 64 fit into 127? Yes, it does.
Yeah.
Subtract your left with 63, 31, 15, 7, 3, 1, and 0. So 255 in binary is equal to 1, 1, 1, 1, 1, 1, 1, 1. all the ones, like bingo, all the ones. Does that make sense? And to check that out,
Yes.
you can just add them up. 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, plus 8 is 248, plus 4 is 252, plus 2 is 254, plus 1 is 255. That is the reason why in binary we go from 0 to 255. Because you cannot make a bigger number than 255 in binary from 8 bits. Can't make it. Now, you will get 256 values because you start at 0. So 0 to 255 gives you 256 addresses. So remember earlier on we were saying the subnet here, 255, 255, 255.0. Well, yeah, we had 256 addresses there because we had 8 bits for your hosts. I'm kind of going a bit into much into this here. Does that make sense, guys?
Yep.
Okay.
Yeah.
So what I want to do is concentrate on why we need the subnet. Now, if we go back, I should have maybe talked about this earlier on. We had a class A with 16 million addresses. We had a class B with 65,536 addresses. We had a class C with 256 addresses. The largest or CISCO recommendation, networks with no more than 100 hosts. So CISCO say you shouldn't have a network with more than 100 hosts. Why is that? In the same network, your network, you should not have more than 100 hosts within the same network. So if you have this class A with 16 million hosts, is that a good recommendation? No. The reason why is because you need to limit your broadcast traffic. Remember, if one device in the same network sends a broadcast message, who does it go to? All of your other hosts. So if you had a very large network with 16 million devices in the same network, you're going to have a hell of a lot of broadcast traffic because they're all going to be sending broadcast messages again and again and again. So it's always a good idea you can make your network smaller. You can divide your network. And how do you divide your network? By manipulating the subnet mask. You change the subnet mask. Once you change the subnet mask, you can make your network smaller. Let me show you an example. Let's say here. Say here, right? Okay, so we have many people. We've got 14 people here. Okay, so I have, let's say this is a classroom environment, and I just walked into my classroom with a big, large apple pie. Okay, all to myself. But I was, and then I look at it, and there's 14 people, there's 13 people there looking back at me very, very hungry. Yeah. So what do? I'm going to take this large apple pie, and I'm going to break it in to smaller pieces. So now I've got 2 pieces. Is that enough for everyone? We've got 14
No.
people. No, not enough. So what do I do again? I take my apple pie and divide it again. We got 1, 2, 3, 4. Is that enough? No.
No.
Divide it again. Divide it again. Is that enough? 1, 2, 3, 4, 5, 6, 7, 8. No, we're still short. So keep need to go again. Now it's going to get tight. Probably excuse the cosmetics part of this thing here. Do we have enough now?
Should do.
Yes, we do. We have 16 pieces. of apple pie to go around the 14 students. And we got 2 left over. So what happened there? Nothing magical. I just took one large apple pie and I divided it into multiple smaller segments. You can do the exact same thing with networks. You can take one network and you can divide it into multiple smaller networks called subnets. But they're smaller, but you got more of them. Because you get like I said, it's this isn't Jesus and the loaves where he took all the loaves and just pointed it out. This is just logic. The more pieces we created, the smaller they got. It's just maths. Okay. We're not making ourselves more apple pie. We're just making more smaller segments. So if we look at the same logic, let me look at the class C. So we said how many addresses in the class C network? So one class C. So one class C network will give us 256 addresses. I'm not talking about hosts, I'm just talking about overall addresses. So one class C, now what do we do if I took that one class C and I divide it into 2 subnets? Two subnets. We use the same analogy, if we use the same logic that we did with the apple pie. So 2 subnets would be what? How many addresses per subnet then?
1, 2, 8.
Yeah. 4 subnets. So keep it team.
64.
Yeah. It's going to be lazy here. I would recommend taking this down because it'd be very useful. So 4 subnets, 64 per subnet. 8 subnets, 32 per subnet. 4, 2, 4, 8, 1, 2, 4, 8. 16 subnets, 16 addresses. Actually, I'm going to change it just a little bit. $32 subnets, 4 addresses. I'm going to just take out this. Yeah. I would definitely recommend taking this down. This will really help you this table. So 32 subnets will give us 8 addresses per subnet. Yeah. 64 subnets will give us 4 addresses. One, 2, 4, 8, 16, 32, 64. No. Does that make sense? So what I'm doing here, I'm making extra subnets, but what's happening on the other side? I'm doubling up in our subnets, but to keep things balanced, because that's all maths is just balancing things on the other side, I have to half over here. So 1 subnet, 256 addresses, 2 subnets, 128 addresses, 4 subnets, 64 addresses, 8 subnets, 32 addresses, 16 subnets, 16 addresses, 32 subnets, 8 addresses, 64 subnets, 4 addresses. Does that make sense? Because if I multiply 8 by 32, I get 256. 16 by 16, 256. 64 by 4, 256.
Go back to what you said there about the CISCO recommendation, the fact that you've got 128 on over 2 subnets, obviously there'll be, is that broken into 2 individual subnets or is that just one subnet?
So if I could have this one here.
Yeah, you're saying that CISCO recommend only 100 hosts per
network. Yeah. So when you see the thing is, the these networks, you don't have to like. They're logical address. They're logical networks. Like you're going to like we've millions and millions of private. We'll start looking at private addresses and public addresses. But internally in a private address, we've no shortage of addresses we can use internally. So you know, if I have to have this a smaller subnet with 128 addresses, well, that's fine. You know, yeah, like okay, it's probably better off with this one here because it's more compact. But that's just a general recommendation. You know, I've seen networks with 128. That's fine, but usually you'd have it here. 64 or even here. It really depends. It really depends. But don't worry about the actual part of that for now. I want you just to make sure that you have that table there. I'll keep this table. Is that okay, guys? So any questions on that there?
Oh.
Okay,
It's gone.
cool. Right, so I'm actually going to look at our first subnetting question. So what I'm going to go into is actually subnetting design, okay? Subnetting design, and because I think it's the best way to learn subnet is by actually designing your network based on a number of requirements. And when you start learning that, if you learn subnetting design, you should be able to handle or tackle any subnetting question. Okay, so here's our first question here. Let me just. Okay, so we have a company, right? We purchased a Class C network. Who did we purchase this Class C network from? If it was a public network, who would you purchase it from? Your ISP. Okay, so we have a Class C network, 216.21.5.0, but we need to take that one network and use it to address this diagram. So how many different networks do we need to take from this one network here? How many different networks are in this diagram?
3.
3. One network.
Small, not one. Remember, every interface on a router is a member of a separate network.
So it's 3.
So you got one here.
Yeah.
You got 2 here. 3, 4, 5. These are LANs. So you could say this is Cork here. This is a Cork network. You could say this is Dublin, and this is Belfast. The network that connects the Cork office to the Dublin office is also a network. Has to be a separate network. So we got 1, 2, 3, 4, 5. Don't worry about that. We're going to be going over that again and again and again and again. So we have one Class C network with 256 addresses. That doesn't satisfy the requirement for this here. We need to take this one Class C network and divide it into at least 5 subnets. Does that make sense? 1, 2, 3, 4, 5. Every interface on a router has to be a member of a different network. You can't, let's look at Dublin here for a second. It has to be a member, otherwise the communication is going to break. Like I can't have Cork being in this network here, 192.168.1.0, and Belfast being over here, 192.168.1.0. Because if a packet comes into Dublin and it's addressed to 192.168.1.1, all right? And Dublin goes, where the hell do I send this to? Do I send it to Cork, which is 192.168.1.0, or do I send it to Belfast, which is 192.168.1.0? So you know, like if you have an air code C1536 3PK1. There's only one air code with that. You don't have an air code like that in Cork and another house with an air code in Belfast, because that's going to confuse the poor postman. It's the same over here. Okay, so it has to have all different subnets. So if we get our table, let me just clear up this chicken scratch here. Okay, we got our table here. Where are we going as far as? How many networks do we need to go? This is why I like this table here. This is what we start off. How many subnets do we need? Is 2 subnets enough?
No,
No. Is 4 subnets enough?
no.
No. We need to go as far as 8 subnets with 32 addresses.
32 addresses.
There's where we need to end up. Now you're going to say, well, we're going to have some left over. That's fine. It's like my apple pie. I've 16 pieces of apple pie. We've got 14 people here. We've got 2 pieces left over. That's fine. If someone wants apple pie later on, we can use that. If we want to add another network or maybe another link here, we can use that. Okay. But so that's yeah, for future growth. But at the moment, we need 5 subnets. This one here is too short. We're shy. We have to go as far as 8 subnets with 32 addresses. 32 addresses in each subnet. Okay. Any questions on that?
Lee, I was just wondering, what's it, when you know how you mentioned the first and the last address,
Yeah.
Are what's it called? They're reserved.
They're
Which
reserved.
one of them? Yeah, which one of them is what's it called? Would you assign to, say, the default gateway?
The default gateway gets to usually it's not written in stone, but usually you give the very first usable host the default gateway address.
Okay.
The very first usable host gets that.
Okay, no problem.
And we'll be doing that when we're actually going to look at routing next week. Really interesting class next week. Routing. It's really where the CCNA starts coming into play, because it's all about routers. But so you can't understand routing, but we'll have to go as subnetting here first. Okay, so there's 3 steps we take in order to learn. We can take any networking design or any network question, and we can answer it with these 3 steps. So step number 1. So this is our question. We have this subnet 216.21.50, which is a class C, and we need to divide it into 5 subnets. Yeah. Now, just before I do that, how do I know 216.21.5.0 is a class C? Remember, what dictates whether it's a class A, B, or C is
255.
yeah. So let's say if I had, if I had 150.51.5.0 and I had a subnet mask of 255.255.255.0. What class is that? Is that A, B, or C?
C.
Let's see.
A or B
Class
or
B.
C?
B.
Class B.
B.
Well, the only requirement it has to have is it's where the first octet lies.
Yeah.
That's all that matters.
Yeah.
Nothing to do with the subnet mask. It's a class B. All the time, this is going to be a class B. The subnet mask is irrelevant. The subnet mask does not make a class A, B, or C. It's the first octet. Okay, cool. Okay, so we have a class C because the 216 is a class C, because the 216 is between 192 and 223. Okay. So these are our steps. Step number 1, determine the number of networks, 5, and convert into binary. That's what we need to do. So we need to convert 5 into binary. We need to say to ourselves, how many bits does it take to make 5? Okay, so we have that table here. Let me just make it a bit bigger. Yeah. Second. So 1, 2, 8, 64, 32, 16, 8, 4, 2, and 1. Okay. How many bits does it take to make 5? Why 5? Because we want to make 5, we're looking to get 5 networks. Okay, so we say 5 in binary. So we say 128 fit into 5? No. 64 into 5? No. 32 into 5? No. 16 into 5? No. 8 into 5? No. So 5, so 4 into 5 is 1 and 1 left over. So how many bits? 3 bits. It takes 3 bits to make 5. That's all you're doing at the very start. You're just finding out how many bits does it take to make 5. So once you know that, then you just erase your diagram, because we've done that question. We found out it takes 3 bits to make 5. Second part. This is where the actual subnetting comes into play. This is your kind of where we start about chopping up our apple pie. We need to reserve those bits in the subnet mask and find the increment. Now, what subnet mask are we talking about? Well, the subnet mask of a class C is default. It's 255, 255, 2550. Yeah. Class C. We know it's a class C. It's even up there, written up there for us. So you take the subnet mask and you convert 255 into binary. What's 25? We've done this before. What's 255 in binary? 11111111. 8 bits. So 255 in binary is 1, 2. Oh, 1 second. I'll put that in black. 1, 2, 3, 4, 5, 6, 7, 8. Dot. 1, 2, 3, 4, 5, 6, 7, 8. Dot. 1, 2, 3, 4, 5, 6, 7, 8. Dot. Let me put this in red. 0, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. All I've done there is taken my subnet mask of the default subnet mask, which is 255, 255, 2550, and I've converted into binary. Does everyone see what I've done there? This is my default. I haven't changed anything yet. Okay. What do I need to do? I need to take 3 bits and I need to convert these 3 of these zeros into ones. Because when it comes to networking, your 1 bits are your network bits and your zeros are your hosts. So your ones are your networks and your zeros are your hosts. We look here. First thing we said, when we said the subnet mask 255 represents the network, 0 represents the host. All we're doing is we're just going a bit further and I'm taking the binary equivalent of 255, which is 8 ones. All the 1 bits represent the network part of the address. All the zeros represent the hosts. So this by default is the network. The black bits here, the black ones are the network, the red zeros are the hosts. We need more networks. How are we going to get more networks? We take from the zeros and we convert them into ones. How many extra subnets we need? We need 3 bits. Why? Because it takes 3 bits to make 5. So I take 3 of these zeros and I make them into ones. 1, 1, 1. What happens to the other 5 bits here? They stay as zeros. Okay. Any questions on that? I'm going to come back, guys. We're going to be doing this all night. I know I can be very confused at the start. Just going to have to bear with me.
Why do we start the conversion of those hosts from the left side?
Very good question. Because you have to consider them as oil and water. They don't mix. You keep your ones together and you keep your zeros together. A proper valid subnet mask will always have the ones together and the zeros together. So once it goes across, once you hit the ones, you have to keep your ones together. That's you're never going to have 0, 0, 0, 1, 1, 1, 1, 1. So think of oil and water. Okay. Another thing I was going to say was when we look, if we go back here, when we look at the default subnet mask up here, 255.0.0.0, yeah. I'm gonna break that into binary for a second here. What's that in binary? 255.0.0.0 binary is what? 1, 2, 3, 4, 5, 6, 7, 8 dot 0, 0, 0, 0, 0, 0, 0 dot 0, 0, 0, 0, 0, 0, 0 dot 0, 0, 0, 0, 0, 0, 0. Yeah. Another term for that is called /8. Okay. And the /8 /8 means that there are 8 network bits in the subnet mask. There are 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 1 bits. It's called CIDR notation. It's another way of writing your subnet mask. CIDR, C-I-D-R, as opposed to the stuff you drink on a Friday night and a summer's evening. Classless internet domain routing. Okay, so it's the /8. Does everyone see where it's a /8? If a class A by default subnet mask is a /8, and what's a class B?
/16.
1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 0, 0, 0, 0, 0, 0, 0, 0 dot 0, 0, 0, 0, 0, 0, 0, 0. By default, that's going to be /16. Yep. By default. There's no difference between 255.255.0.0 and the /16. They are the exact same thing. It's just another way of writing it. You're just saying there are 16 subnet bits, 16 ones. So when it comes here, again, I can't stress it enough. Your subnet bits, your ones are your subnet bits, your zeros are your host bits. So class C, what's your default subnet bit of, or your / notation of a class C?
/24.
Yeah, 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 0, 0, 0, 0, 0, 0, 0, 0, which is /24. Okay. So over here, our default one here of class C is what? /24. But we've changed. What's our new subnet mask going to be? It's going to be /111111111. What?
27.
27. Very good. Because you add on those. So we're adding on an extra 3 bits onto our original subnet mask, Why is it 3 bits? Because we needed 3 bits to make our 5 subnets. We're borrowing, we're converting 3 of these zeros into ones. We still have, how many bits of hosts have we still left? 5. 1, 2, 3, 4, 5. Okay, what's your new subnet mask going to be now?
255,
255,
255, 257.
255, 255, 255. Now we have to take this here, 111, 0, 0, 0, 0, 0, and we have to convert it into decimal. 1, 1, 1, 0, 0, 0, 0, 0. Because that's how we're doing it here. We got all 8s and we convert that into decimal. We have 255. All the ones here, 255. All the ones here, 255. We were only doing the first 3 bits here. So 128 and 64 is 192 and 32 is 224. 255, 255, 255, 224.
I see. Yeah.
Is that okay?
Yeah.
Okay, so what we've done here is we have reserved the bits in the subnet mask, the 3 bits, because it took 3 bits to make a 5. We look back to the question here. We had 5 subnets, took 3 bits to make those 5. We need to find the increment. Now, what the increment, the definition of an increment, right? I'll write this down here. So an increment is the number in which your new subnets even will increment in. It's the number which your new subnets will increment by. The increment is always the last, let's say quotation mark here, 1 bit converted into decimal. So the increment value, the increment is a numerical value in which our new subnets will increment by. The increment value is always the last subnet bit converted into decimal. So where's our increment? Well, it's here, isn't it? This is the last subnet bit, this guy here. We convert that into decimal. Our increment is 32. Our increment value is 32. This increment value tells us that our new subnets will increment in the value of 32. The increment is the value in which your new subnets will increment by. It's always the last 1 bit converted into decimal. It's not here or here or here, because they're not 1 bits, they're zeros. Okay. I know it's confusing, guys. You have to just bear with me on this. We're going to be doing all day tomorrow as well, and we're doing a lot more. So we're going to put a lot of work into this, especially for the new guys. I feel for you. I really do. But that's what the videos are there for. That's the beauty of the videos. You can go back over it again and again and again. Okay. Now, if we go back to our notes, where did we see this before? 8 subnets, 32 addresses. It's not by fluke that the increment is also the number of addresses. So each subnet is going to increment in the value of 32. So where do we start off at? You start at the start. You start at 0, because 0 is always the perfect starting point. Let me just read this. So our increment is 32. So you use the increment value of 32 to find the network ranges. So you'll say the first network or subnet is 216.21.5.0. Second network is 216.21.5.32. Why am I saying 32? Because it's the increment. We know our increment is 32. So we're writing down, we're using the increment of 32 to find our network ranges. Each subnet will increment in the value of 32. Third network, or third subnet, you see these are subnets. A subnet is just a small network. I use them interchangingly, the term interchangingly. So
216.21.5.64.
Fourth is
96.
216.21.5.96. And then the fifth
128.
21.5.
128.
Yeah, that's it. Now, what's the very last address in the first network? Remember, the first network only has 32 addresses in each network. We said that. And you can't have an address in the first subnet and in the second subnet as well. They have to be unique. So I see what you're doing there, Richie, but it's the very last address, not the last usable host. So it'll go as far as 216.21.5.31. That doesn't work. 216. The next, very last address in this network would be 63. The very last in this network would be 95. 127. And then this guy here would be 159. There can't be any overlap. Every network has to have a unique set of different IP addresses. So the first network, all of the addresses in the first network will live somewhere between 216.21.5.0 and 216.21.5.31. Now remember, how many hosts? Only 30 hosts, because you can't use the very first address, and you can't, because it's network ID, it can't use the very last address, which is the broadcast. So this here, you would say, is your network ID of each one. Unusable, and this is the broadcast. Unusable. So what's the what is the very first address in the third subnet? What is the first usable host in the third subnet? What's the first usable host in the third subnet?
216.21.5.65.
Exactly. That's it. Yeah. Very good. Very good. Okay, and the new subnet mask is going to be 255, 255, 255, 224. Okay, so where, again, if we get the table here, where did we start? We started off with one class C, which by default has 256 addresses, and we took that one class C network and we divided into at least 8 subnets. We had to go as far as 8 subnets because 4 wasn't too much. We've got 8 subnets, which would satisfy the requirement of 5 subnets. And we've got 3 left over. So we could keep going. I could keep going and make another 8 subnets altogether. 0, 32, 64, 96, 128, 160, 192, and 224. And there's me 8 subnets. Each of those subnets is 30. So 8 subnets with 32 addresses. There's another way, there's a formula that when you have the subnet mask, you can count out how many subnets and how many addresses. So how many bits did we borrow to make subnets? 3, wasn't it?
3 bits.
So you can say, this is the formula, you say 2 to the power of the number of the bits. So 2 to the power of 3 is 1, 2, 3. That means 2 by 2 by 2 is 8. So when you say 2 to the power of 3, you're saying 2 multiplied by itself 3 times, which is 8 subnets. So that 2 to the power of 3 is 2 multiplied by 2 multiplied by 2, which is 8 subnets. How many host bits do we have? 5. 1, 2, 3, 4, 5. So you say 2 to the power of 5 equals, so that's going to be 2 by 2 by 2 by 2 by 2, 32 addresses. 8 subnets, 32 addresses. 8 subnets, 32 addresses.
Was it by
Yeah, sorry,
coincidence
go ahead.
was it by coincidence that the increment was 32 or
No coincidence. In a class C network, the increment will always be 32.
32?
Will be the number of addresses. Yeah. Yeah. Which is very useful for use. Okay, it's 8:30. That hour and a half flew in. We'll take 15, grab a cup of coffee, bun or something, so vodka, something strong, and we'll come back then at 1:45. Take 15.
All right, sorry, can you bring up the slide where you write the increment of
Which this?
yeah.
So the increment is a numerical value in which a new subnet will increment by. The increment, so we found our number because it was always the last subnet bit here converted into decimal. So where's our last subnet bit? Where's our last subnet bit? Here, it's here, isn't it? 1 1 1 0 0 0 0 0 1 1 1 0 0 0 0 0. Our increment value is always the last subnet bit converted into decimal. This is here. Is that okay?
Yes.
Don't worry, we're going to do this again and again and again. I'm going to give a hand up. I might do one more, and then I'm going to give you to do some. So let's say I had Tom and I had Bob. Okay, and they were connected into a switch. Switch in the middle, right? I'm not going to put lines here. Okay, so let's say they're connected in here and Bob's connected in here, right? And Tom's IP address is 216.21.5.34/27. And Bob's IP address 216.21.5.30/27. Would Tom be able to ping Bob there? Yes or no?
Yes.
No.
So we have we have a yes and a no.
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 Like a
No.
network.
Different networks. Yes,
Different
different networks. Because look, Tom lives in network number 2. His IP address is 216.21.5.34. So this is Tom. Bob is the very last address in network number 1. They're in different networks. So even though they're like 4 IP addresses away from each other, they're in separate networks. They're all different subnets. There's a good example to kind of show the actual practical purposes of it. This is the reason why we subnet. Okay. I'll do another question. I'm going to do another one, and then I'm going to get used to do one. I don't know whether, yeah. So let's have a look at this one. Okay, we got class C 200.1.1.0. We need to divide it into 40 subnets. 40 subnets. Okay, so what we need to do here is go back to our little table that I said is so very useful. And where do we need to go on this? Where do we need to end up?
4 subnets.
So we need to go as far as? Yeah, that's where we need to finish. 64 subnets, 4 addresses. Because 40 subnets, the only thing that satisfies the requirement of 40 subnets is 64 subnets, 4 addresses. 32 subnets, you're short. We're short of 8 networks. So we need to get as far as here. Is that right?
Yep.
Okay. Step number 1, determine the number of networks converted into binary. Okay, again, so it's always useful to have my table. I should have just open up my table again. So it's 1, 2, 8, 64, 32, 16, 8, 4, 2, and 1. So determine the number of networks, 40, convert into binary. All we're doing at the very start is finding out how many bits does it take to make 40. Okay, so 40 is equal to
8.
0, 0. 128 doesn't fit in. 64 doesn't. You have 1 here.
0.
1, 0, 1, 0, 0, 0.
Yeah.
Yeah. How many bits?
3, 4, 5, 6 bits.
6 bits. So it takes 6 bits to make 40. First part is done. So we look at the second part now, right? 6 bits make 40. Seconds.
So the increment.
Yeah. Okay, so that's done there. So we go into the second part. So we need to reserve those bits in the subnet mask and find the increment value. So it's a class C. The default subnet mask for class C is 255.255.255.0, yeah? So we'll write down the default subnet mask in binary. Now it's in binary. So it's 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 0, 0, 0, 0, 0, 0, 0, 0. And that there is a slash.
Slash 8, 24.
24. Yeah. Now, what are we going to be doing? We're looking for 6 bits of what? Network. We're looking for 6 bits of ones, extra ones. Your 1 bits is your networks, your zeros are your hosts. Okay, your 1 bits are your networks. That's so important. Zeros are the hosts. It's all about the ones and the zeros.
4. So the equals will be 4.
So you take 6 of these zeros, yeah, and you convert them into ones.
Ones.
So 1, 2, 3, 4, 5, 6. Why 6?
6 bits.
Because it tells 6 bits to make 40. Yeah. Then your slash notation goes from slash 24 to a what?
8, 16, 24.
30. Yeah. We're just
30.
adding the 6 bits to be borrowed
Ones.
plus the 24. So your new thing is going to be slash 30.
Slash 30, yeah.
Now to get your subnet mask, well, all the ones is 255. Again, bingo. All the ones, 255. All the ones, 255. 1 1 1 1 1 1 0 0. So you take that and you superimpose it on a table. 1 2 3 4 5 6 0 0. So 128 plus 64 is 192 plus 32 is 224 plus 16 is 240 plus 8 is 248 plus 4 is 252. So your new subnet mask is going to be 255 255 255 dot 252. Is that okay, guys?
Yep.
Okay, cool. So use the increment to write your network ranges. Now let me just have it. What did we say about the increment? We said the increment is the numerical value in which your new subnets will increment by. The increment is always the last subnet bit converted into decimal. So where is our increment value here?
4.
Yes. Because this is here. This is your 1 bits of your network, your 0. So it's always the last 1 bit, the last subnet bit converted into decimal. Our increment value is 4. So you can say your inc is 4. Where did we see that before? 64 subnets, 4 addresses. Somebody asked was a coincidence earlier on. In the last question, and the same thing again. Is it a coincidence? No.
No.
Not for class C. Class B, different story. We won't go there yet. Okay, so use your increment to write. I'm not going to do loads. I'm not going to do 64 subnets because we just there. So we'll just draw the first 2. So your network number 1. Now where do you start? You start at the start at 0. So you could say network number 1, 216.21.5.0. Network number 2, 216.21.5. What's your increment value? 4. So your subnets are incrementing the value of 4. Network number 3, 216.21.5.8. 048. And I could keep going and I'd get until I make 64 now. 64 multiplied by 4 is 256. What's the very last address in subnet number 1?
3.
Yeah. So 216.21.5.3. The very next one here, subnet number 2. 5.7. Yeah. And then 216.21.5. 11. Yeah. Now remember these ones here, your network ID and your broadcast, you can't use. Network ID and the broadcast address. So how many usable hosts have you got?
2.
2. That's it. 2. 2 usable hosts. Would you say that's a very big network? Would you say it's a very common network? A network with 2 usable hosts?
Would that be the case for like what's called like peer-to-peer communication?
Exactly.
If it's end-to-end encrypted or something.
It's one of the most common subnets you can have is a /30. Why would you give, let's say, 30, like let's say, why would you give 126 addresses here on this network? You only need 2, point to point, here and here. So when you have 2 routers connected together, usually you'd use a /30. So you could say if we 192.168.1.0/30, and this would be 1.1, and this would be 1.2. That's all you need. That's the smallest. It's one of it's the smallest network you can have. Now, I would confuse things by talking other things, but I don't want to. We'll just keep it as that. 192.168.1.0/30. Yeah, 1.1 here and 1.2. So here, so obviously these 40 networks, they're not going to be you're not going to have 40 LANs, because you're not going to have 40 offices, because each office isn't going to have 2 usable hosts. It's not going to be very useful. You're only for point-to-point networks. Can you remember the formula that we used to find out? I know we had the table, but what was the formula to find out how many subnets and how many addresses?
Oh, something to the power.
It's like
So yeah,
2 to the
so
power of,
we could say, how many subnet bits did we borrow? 6, wasn't it?
6.
1, 2,
6,
3,
6,
4,
6
5,
to the power
6.
2.
2 to the power of 6 equals 64. 2 by 2 by 2 by 2 by 2 by 2 by 2, and then 64 subnets, because these are blue bits are the subnets are the subnet bits we borrowed. We borrowed 6, and then we still have 2 bits for your host. So you say 2 to the power of 2 is 4 addresses. Okay. Cool. Any questions on that, guys? I want to give you one to do yourselves. I'm talking for the last 2 hours. I'm hoarse here. A bit of a cold as well. So, right. Let me get you just one to do. What one is this one here? Cool. Give us 5 minutes. But put on your chat whenever you're finished. It's not a race. It's not a race. Some people will take longer than others. But have a go at that. I'm going to pause the recording. No, you didn't hear you saying bollocks, Graham, so you're all right. Right. So where do we need to get? We need to go as far as 16 subnets, 16 addresses, yeah? Because look, you're looking for 14 networks. 1 doesn't cut it, 2 doesn't cut it, 4 doesn't cut it, 8 doesn't cut it, 16 does here. Okay. So 4 bits. So we know it takes 4 bits to make our 14 networks. Get rid of this guy here. Put down there. Okay. And the second part is reserve those 4 bits in the subnet mask and find the increment value. Okay, so your default subnet mask is 255.255.255.0. Put that in there. So 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot, and then 0, 0, 0, 0, 0, 0, 0, 0. Okay. So what do we want to do? We want to have 4 bits of what? We're looking for 4 bits of networks. So we need to convert 4 of these zeros into networks, because we're looking for 14 extra networks. But we have to take from something, so we're taking from the host bits. We're taking 4 of these zeros and we're changing them into ones in order to create an extra 14 subnets. 1, 2, 3, 4, 0, 0. So how many? So you that by default there you have a /24, and that goes from /24 to a /28.
2 to 8.
Your new subnet mask is going to be
255, 255, 255, 2 to 8.
255, 255, 1111. So it's going to be 1, 1, 1, 1, 0, 0, 0, 0. 128 and 64 is 192 and 32 is 224 and 16 is. So 128 and 64 is 192 and 32 is 224 and
240.
16 is 240. Yeah. So 255, 255, 255 dot.
240.
Yeah. Where is your increment value?
The 16.
The increment value is always the last, is subnet in which a new subnet is an increment. The increment value is always the last number, 1 bit, converted into decimal. Increment value is always the last number, 1 bit, converted into decimal. So our increment value here is 16, which means our new subnets will increment in the value of 16. Is that okay?
Yeah.
Okay, so our increment is 16. So I'm only going to write a couple of the networks. I'm not going to do many of them. Oh, crap. One sec. So network number 1. Say blue. Subnet number 1, subnet number 2, subnet number 3. So network number 1 is going to be, you start at the start. 0 is always a perfect starting point. You say 199.9.10.0. Second network is going to be 199.9.10.16. Increment is 16. It's a value in which your new subnets will increment by. This subnet first network is going to go as far as
15.
yeah 199.9.10.15 199.9.10.31 199.9.10.47. And I could keep going. How many subnets would they end up with? 16. How many addresses?
16 subnets.
16 subnets. 2 to the power of 4, because we've got 4 blue bits, is 16. But we also got 4 host bits, is 16. 16 subnets, 16 addresses. All right. Okay. Any questions on that?
No.
Okay, cool. Let me just close this. And okay, so all of our kind of questions that we looked at so far, we've been subnetting based on an X amount of networks. Yeah. So we're like the last, if we look at the last question there, or one of the questions was, we had to break this network into 40 subnets. And the other one was breaking into 14 and so forth. Now I'm going to change it up though. I'm going to change tack. I'm going to have a look at this guy, but it's changed. The requirement is changing. If you want to do that one, I'll do this one. No, 1 second. Where am I going this? Sorry, my bad. What's happening? Is this the same one? Have we done this? No, because it's saying our requirement has changed. It says we have 200.1.1.0 break into networks of there must be at least 40 hosts. 40 hosts. All of our questions to date were basically saying we must have X amount of subnets. Now it's saying we must have X amount of hosts. So create as many networks as possible, but you must have 40 hosts. So this is where our table comes in. It's still very useful, but instead of looking at the left here, we need to look at the right. So 256 does satisfy it, but we want to have as many as possible. 128. Yeah, we could make more though. 64. Well, what about this one? 32. Well, we can't make 32 because we're shy. So we need to go as far as
64.
64. Yeah. So we need to end up here. 4 subnets with 64 addresses. Okay. Just be wary of the way this is phrased. We're subnetting based on the number of hosts per subnet.
Okay.
Okay, so number 1, determine the number of hosts and convert it to binary. We're looking for 40 hosts. Okay, so we need to convert 40 into binary. So how many bits does it take to make 40?
6 bits.
It is 6 bits, yeah. 1, 2, 8, 64. Yeah, so I won't even do it because we know it's 6 bits. Is that okay? So it's 6 bits. Now I'm going to write this in red for a reason. We need 6 bits. Now let's look for a host. Is a host a 1 or is a host a 0?
Host is a 1.
Host is 0.
Host is your subnet bits are your 1s. Your host bits are your 0s, yeah? So the next part is to reserve those 6 bits in the subnet mask. Okay, so our subnet mask hasn't changed. It's still a class C. So it's going to be 255, 255, 255.0, yeah? So we say 1, 2, 3, 4, 5, 6, 7, 8 dot. 1, 2, 3, 4, 5, 6, 7, 8 dot. 1, 2, 3, 4, 5, 6, 7, 8 dot. 0, 0, 0, 0. 0, 0, 0, 0, which is /24, yeah? No, this hasn't changed yet. This will change though. What are we looking for? What is the requirement saying that we need?
More hosts.
6 bits.
6 bits of zeros. So it's saying we need to create more networks, but we have to have 6 bits of zeros. We have to have 6 bit zeros in our subnet mask. So if we can do whatever we want to the zeros, but we have to have 6 bits of zeros in it. So in this case, yes, you actually start on the right and you reserve your 6 bits of zeros. 1, 2, 3, 4, 5, 6. Whatever's left over, you can turn into 1s. Do whatever you want to do, because we've just satisfied our requirement. Our 6 bits of zeros are still there. And that's going to go from /24 to a /26. Yeah.
Sorry, Lee, how did you quickly got that 6 bits?
Okay, let me go back. 128, 64, 32, 16, 8, 4, 2, 1, 40 hosts. So 40 in binary is equal to 0, 0, 1, 0, 1, 0, 0, 0. 1, 2, 3, 4, 5, 6. So 40 is equal to 6 bits. Does that make sense, Evan?
Yeah.
Okay, guys, I'm actually going to leave. Nothing. I want you to finish off the rest of it for me there. Okay. just take a couple of minutes, just finish off the rest. I want to find out the subnet mask, and I want you to write down the networks
The increment.
and the increment. Find the subnet mask, find the increment, and find the networks. Just finish the question in the same format. It's everything else after here is the exact same as the way you've been doing it. Just go to pause recording again. Okay. Sorry, we should have resumed that there, but we'll do another one. I'm gonna get you to do another one here. We done that one now, did we? We just did that one there, didn't we? Yes. What about this one here? That's the same one, 201.1.0, 40 hosts. Right, what about this guy here? Okay, there you go. Obviously, guys, we'll give us maybe 5 minutes quickly to go through that there. See how far you get, yeah? 199.9.10.0. We're looking for 12 hosts. So we're looking for bits of zeros. 12 hosts, yeah. I'm going to do this quick because I will still want another, still a good bit of stuff left to go through. Okay, so how many bits does it take to make 12? Actually, I'm going to do it because just I don't like to take shortcuts on this. 128, 64, 32, 16, 8, 4, 2, 1. So 12 is equal to 0, 0, 0, 0, 1, 1, 0, 0. So it takes 4 bits, yeah? Is that okay, yeah? So we're looking for 12 hosts. So hosts are your zeros. So we need 4 bits of zeros in our new subnet mask. Is that okay?
Yeah.
Cool. 4 bits of zeros. All right. So step 2, reserve the bits, there's the 4 bits of the subnet mask and find the increment. So your default subnet mask is 1, 2, 3. No, 1 sec. Should be putting them in black. 1, 2, 3, 4, 5, 6, 7, 8. Dot. 1, 2, 3, 4, 5, 6, 7, 8. Dot. 1, 2, 3, 4, 5, 6, 7, 8. Dot. 0, 0, 0, 0, 0, 0, 0, 0, which is a /24. What it's saying is we need to have 4 bits of zeros in the subnet mask. So you stay on the right, 0, 0, 0, 0. Anything else left over can be turned into ones. 1, 2, 3, 4. Remember, a proper subnet mask will always, the ones will always be together. The zeros will always be together. And they're never going to be mixed. It's always ones all the way across. And then as soon as it hits a 1, 0, everything else after that will be zeros. Does that make sense? /24 to /28. Our new subnet mask is going to be 1, 1, 1, 1, 0, 0, 0, 0. Yeah. So our increment value is going to be
16.
16. Yeah. So that tells us our new subnet is going to increment in the value of 16. So you can say network number 1 is 199.9.10.0. Network number 2 is 199.9.10.16.
16.
And the subnet mask?
255.255.240.
That's it. 255, 255, 255, 240. The increment value, yeah, so we've done the increment value here is 16. And the very last address in subnet number 1 is going to be 199.9.10.15. Yeah. Okay, cool. All right, I'm going to look at class B now. Right now, yeah, I'm going to do this myself. I'm going to do this switches because it's bigger. So see this thing here, this doesn't make, we can't do this anymore. Well, the increment is still the same, but obviously this table is useless to us because this is only for Class C. Because remember, one Class B network is going to have 65,536 addresses. Where are we getting those 65,000 from? If we go back. Here. The reason we're getting those 65,000 is because we have 16 bits of zeros there. 16 bits of zeros. So if you go 2 to the power of 16, 65,536. 65,536. Yeah. Okay. So yeah, it's bigger, much bigger. But this concept remains the same. The 3 steps remain the same. Okay. So it's a Class B. How do we know it's a Class B? Because the first octet, 170, is between 128 and 191. That's the only criteria. But we need to break into networks of 1,000 hosts. So we need to, first thing we need to do is find out how many bits it takes to make 1,000. So we use our table again. 1. Now somebody say 8. It's not 8. It takes more than 8 bits to make 1,000. So we need to go past 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 1248, 16, 32, 64, 128. Yeah. So now you say the 1,024 fit into 1,000. No, it doesn't, but everything else does. So it'll be something like this: 1, 1, 1, 1, 1, 0, 1, 1, 0, 0, something like that. It doesn't matter. How many? All we need to do is find out how many bits does it take to make 1,000. How many bits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It takes 10 bits to make 1,000. But what are we looking for? 10 bits of ones or 10 bits of zeros?
Ten bits of zeros.
1,000 hosts, 10 bits of zeros. Yeah. So that table, I don't need this anymore. Because I was only using that to find out how many bits does it take by 1,000. That's all. So the second part is reserve those 10 bits in the subnet mask and find the increment value. Okay, so what's the subnet mask of a Class B? 1, 2, 3, 4, 5, 6, 7, 8 dot. 1, 2, 3, 4, 5, 6, 7, 8 dot. 0, 0, 0, 0, 0, 0, 0, 0 dot. 0, 0, 0, 0, 0, 0, 0, 0, which is a slash?
16.
16, yeah. What do we need to do? We need to have at least 10 bits of zeros in our new subnet mask. So where do you start? Do you start from the right or do you start from the left?
The left.
So this guy here, you start on the right, yeah? Remember, your ones have to be the same. If we started off on the left, we'd have ones over here. You keep you started, when it comes to zeros, you start at the right and you work your way that way. 1, 2, 3, 4, 5, 6, 7, 8 dot. We're still only 8 there. We still have to have another 2 bits. 9, 10. What can happen to the other 6 zeros here? Ones. Yeah. 1, 2, 3, 4, 5, 6. Then that turns from a slash 16 to a what? $22. You're just adding up all the ones. 8, 16, 17, 18, 19, 20, 21, 22. What's your new subnet mask? 255. 255. Now I'm going to take a table here. 128, 64, 32, 16, 8, 4, 2, and 1. 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6, and then 0, 0. So our new subnet mask is going to be 255, 255. 128 and 64 is 192 and 32 is 224 and 16 is 240 and 8 is 248 and 4 is 252. 255, 255, 252.0. Now, what is our increment value?
4.
The increment value is
4.
4. Okay. Does everyone get that? Our increment is the last subnet bit converted into decimal. Our increment, it doesn't change. Kind of. Right? So now, write our first network down. First network is what? 170.50.0.0. Network number 2.
170.
Yeah.
50.
Yeah.
4.0.
Very good, Edmund. The increment value is 4, but it's 4 in the third octet.
And the user, the host,
So it's not 4 in the fourth octet. There's a big difference when you increment something in 4 in the fourth octet, because your 1 is here. Your 1 bit is in the third octet, not the fourth. When it was in the fourth octet, it was 4 addresses, remember? But now we've got far more. An increment of 4 in the third octet will give us loads more addresses. Does that make sense? Cool. And I'm only going to write 2 there. So, okay. So what's the very, just be careful on this one. This is a bit of a gotcha. What's the very last address in network number 1?
Is it 3.255?
170.50.
Awesome. 3.255.
Yes, very good. Yeah. And their very next address is 170.50.4.0. Yeah. Good. And this will go to. I'm just being anal here trying to get this all right. So it'll be 170.50.255. Yeah. That's it.
So does that leave you with 1,018 hosts, or?
Well, okay. So you see now with our table here, we can't use it. So now you're never going to get this question in the exam because it's just too much to calculate, and you won't have a calculator in the exam either, by the way. Sorry to. But we're doing it here. So change this to a normal standard. Can we do a standard? Yes, we can. So what we're doing is 2 to the power. Oh, no, that's square. I don't want that. What am I doing this? Maybe programmer, scientific. 2 to the power of, so many bits, how many red bits do we have here?
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 to the power 10. equals 1024. So we got 1024 addresses. And does that satisfy a requirement of 1,000 hosts?
Yep.
Yeah. And how many bits? 1, 2, 3, 4, 5, 6. 2 to the power 6 is 64. 2 by 2 by 2 by 2 by 2 by 2 by 2 equals 64. So we have 64 subnets with 1024 addresses.
Mhm.
So if you think about it, right, a class B on its own by default will give us this network here, unchanged, is one large network with 65,536 addresses. We took this one class B and we divided it into 64 subnets, and each of those 64 subnets will give us 1,024 addresses per subnet. That's a confusing one. But the steps haven't really changed though. But what here is you need to be careful of where the increment is. The increment is 4, but it's 4 in the third octet. Which means we've got much more addresses when your increment is 4 in the third octet than you would have if it was increment of 4 in the fourth octet. Does that make sense?
Yeah, just so you said that 64 subnets with 1,024 addresses per subnet.
Yeah.
But obviously, if we're going from 170.50.0.0 up to 255, is that not one subnet?
Very good question. Right, let me just clean this up. We'll just look in at one here, right? So let me just take packet tracer. Got a PC? Okay. And we're going to say 170. Let's say if this is, let's say, look at this one here. This address 170.50.1.0/22. Is that valid?
No.
170.50.1.0. Not valid. Let's have a look. We're just going to, where's bloody packet tracer here? I'll put in the unit mask here first. 255, 255, 252.0. And then here, 170.50.1.0. No, that's fine.
Take it.
Why did it take it? What's the only conditions for an IP address of a host being not valid? It cannot be the very first IP address,
Or the
or
last.
it cannot be the last. In this subnet, this IP address 170.50.1.0 is somewhere here. So that's a very valid address. Like another one would be valid, would be like, so I'll give him that address there. And I'm going to give this guy here, I got another PC, and I'm going to give him, I need to put in the subnet mask first for some reason, 252.0, and I'm going to give this guy a different address. I'm going to give this guy 170.50.2.2.255. Now that looks like a broadcast address, doesn't it? But it's not.
It's not. No.
No, because it's not the very first one. It's still right. It's somewhere in the middle.
Yep.
These two devices would be able to ping each other. Just get a switch. So what did I say? This was 1.0, 1750. Okay, so I'll just put that in. 1750.50.1.0. And this one here is 170.50.2.255. Okay, that's the addresses that we gave on them. Let's go into a PC. I'm going to ping 170.50.2.255. Okay, ping fine. So valid host address.
Let's see.
See, the subnet mask is a very, very powerful tool, because normally you'd look at this, you go, no way is that a valid host address. Like if this was a /24, then it wouldn't be valid, because it would be the very first IP address in that /24. But because it's a /22, it's putting that address in this network here, which is in the middle.
Mm-hmm.
Good. Okay, any questions at all on that, guys? Before we call it a wrap, there was another type of question that I want to go through. We're not going to go through it now because it's 2 minutes to 10.
Oh, good. Good class.